Alright, so in this video we're going to look at a little bit newer of a concept probably for most of you guys, and that's pressure. So pressure, right, is a word that is used a lot in common speak, right? But the physics definition is going to be is an amount or a force applied divided by an area. Alright, so it's going to be an area perpendicular to the force over which it is applied. So if I have a cylinder, if I apply a force on this area, I am applying a pressure. So pressure is simply force over area. And the SI unit for pressure is the Pascal, PA. Now that's named after a scientist named Blaise Pascal. Oh, I almost wrote his first name twice. Okay, if you've ever seen these, like this combination of tubes, right, it would look something like this, and then you would have like a bulb, and you would have, you know, something like this. These are actually called Pascal tubes, right, and it's what he did to study pressure and so forth at different depths and everything. Okay, now for us here in the United States, a more common unit is pounds per square inch, right, or PSI. So a thing to note, that force and area have an inverse relationship. If I exert a force on something but I decrease the area, the pressure is actually going to go up, so the pressure will increase. Now this is the reason why people who wear high heels say their feet are hurting after they wear them. It's because the area of contact is smaller compared to their weight. Right, and so if I have like a tennis shoe or a flat bottom shoe, I have one cross-sectional area, but if I look at like a high heel, this is my only, right, these two pieces are, you know, my area, where the area of the flat bottom shoe is going to be greater than the area of the high heel, which then if I kind of do a little comparison, you're going to find that the pressure of the high heel is going to be greater than the pressure for the flat bottom shoe. Okay, so here's an example. It says an astronaut is working outside of the International Space Station where the atmospheric pressure is essentially zero. We'll get into the reason why that's important here in a little bit. The pressure gauge in her air tank reads 6.90 times 10 to the 6 pascals. What force does the air inside of the tank exert on the flat end of a cylindrical tank, which is a disc of 0.150 meters in diameter? Okay, and so we're going to start with our equation. Pressure equals force over area, and so we're looking for force, so it's going to be pressure times area. So we have 6.90 times 10 to the 6 pascals. Okay, it tells us a cylindrical tank, so the area that it's exerting this force on is going to be a circle, but they give us a diameter of 0.150. We need to put that into a radius, 0.750 squared, right? And so how much force is being exerted on that tank? 1.2 times 10 to the 5th newtons, and that's a bad 5. Give me 1 second, we can better 5. Okay, now fluids cannot withstand shearing, right, which again, remember, is that sideways force, all right, and so they cannot exert the same force. Therefore, fluid pressure has no direction, being a scalar quantity. And the forces due to pressure have well-defined directions. They are always exerted perpendicular to any surface, and that's what they're showing in this picture here, right? And so even the little inset where if I'm, okay, like, so all these force vectors, right, are exerted perpendicular to the surface of the wheel here, and even at the stem where you put the air in, right, all that air pressure is being exerted perpendicular, right? And so from here on out, we're going to talk about pressure, okay, for a little bit, all right?